Okay, I'm really excited to present the next speaker. Artificial intelligence really sort of makes me curious. I want to learn more about this. And here we have a person who is passionate about artificial intelligence. How great isn't that? A big applause for Leonard Johard. Welcome.
So thank you. This talk is going to be AI developments in sustainable development. And just to explain the title, what is sustainable development in this term? Well, it's about software development. We want to develop software that adapts to the outside world in case we have, for example, a market. Our system adapts automatically to the market. And also, it's a more efficient way to develop software and solutions and algorithms than to write it ourselves. So in that way, I think it connects great with the theme today of sustainability. So first, briefly about myself. I've always been passionate about AI, basically. I wrote my first program in C++ at 11, which is quite late in terms of computer guys. But I've always been more of an algorithm person, doing math and stuff. So at 17, I wrote my first neural network in C++ also, and I got kind of addicted and think I want to make this my future. And now, 16 years later, I still write neural networks in C++, so sometimes I have these moments when I question what has really happened and how I developed, but things are moving forward, for sure. So briefly about me, what my colleagues think I do, and I'm a researcher in artificial intelligence. I studied in Italy, did robotics, originally from Royal Institute of Technology, a physics background, which is very common among AI experts today. So one of my big projects today is called Biodynamo. We're developing a new cloud-based brain simulator. So you can see one neuron here. It's quite complex with its structure and its connections to other neurons. And we want to simulate about 10 billion of those. And you can do that only today in a supercomputer, basically, but that's too expensive, like a cluster in CERN, etc. Instead, we're now trying to do this in the cloud with a more economically feasible solution. It scales better, etc. So this is a project led by CERN Open Lab, and I'm one of the algorithm developers, main ones for structuring this problem, how to divide the problem in 3D, etc. So it scales well. But this is just like my day job. My real passion, first I can show you the little demonstration of what I'm talking about. Does this play? So this is a simulation where we have the growth of axons. This is actually not our software. Our software looks better, but this is the kind of simulation we have. I haven't reached the beta version in time. But we can see with very simple algorithms, here the neurons excrete gradients of different chemicals. And then the neurites here, they grow in the direction of the chemicals until they hit a certain concentration, and then they diverge and split, etc. And we create quite complex, biologically realistic networks of connections in this way. And the role of this simulation software is to do brain development. So we don't simulate just an adult brain and see what happens. We're trying to start from a single cell, make it grow up until a full human brain using these kind of natural principles, and then be able to control, say, a robotic body and learn to walk. So the whole process a little bit shortened to make it realistic in a simulation, but the essential principles. And this is very possible today. Is it here? Yes. But actually, what I think I do, this is more like my real passion. And that is create the next generation of artificial intelligence. So the buzzwords you hear today about deep learning, etc., that is really technology from the 90s. So it's nothing new. It's just been, people have figured out, it took them 10 years to figure out what is state of the art. And then around 2006, they started to do things according to the best principles known. But nothing has really happened since then. So we need something new in order to be able to solve new problems. And to do that, we need new algorithms, and that's my real passion. So I think I've developed about 6 new algorithms to create a little package. Missing just one, then we are ready to go to the next step. And it's going to be like not 95 technology, but 2020 technology, so a completely new generation of how we develop things. And this is in order to realize an old, naive childhood dream to create the first robot factory to be able to industrialize artificial intelligence in robotics. And I think it will be possible within our lifetime, say, much faster than we think. We will have these factories ready in 10, 15 years, I guess. So, to not go too much detail, this is what my mom think I do, basically. Something complicated. And I don't know if everybody's interested in the mathematical principles, so I'll leave them for now. If you have want any more details about what is going to be the next generation of algorithms and so on, just wait until afterwards. You can ask me questions about specifics. So I'll try to keep it a more overview of what's happening. To start with some things that people commonly think about AI, we've heard they say that AI is able to reason like humans. It's kind of mimicking how we think. It will replace human workers pretty soon in industry. The technology is pioneered by the tech giants like Google, Amazon, Microsoft, etc. It requires big data to be effective, and you need quite a bit of investment to make some practical systems out of it. So what AI really does today, actually, is imitation. It's the highest form of flattery to us humans, but to do an AI, you can't just send it out in the world and let it learn by its own. You need to give it examples. So you show it a cat, you tell it this is a cat. You show it a dog, you tell it this is a dog. And you've done it enough times, you can show it a new picture, and it can guess what it is, basically. Nothing more complex than that. And this is not the way humans act, so it doesn't learn like humans at all. There are some similarities in how the calculations are done with neural networks, but it's not human intelligence in any way. I try to liken the intelligence level we're at today with some bug. Something like that, an insect. It doesn't have any high-level abstract thinking. It can't have high level of reasoning. Some people debate that with deep learning, but I say definitely not. But still, if you look at the insect world and so on, they have amazingly complex behavior. We can't imitate their movement patterns with known robotics, etc. They're really fantastic creatures, but we need to know the limitations. An important thing to note is that they're electronic, or they work in the actually virtual. They work in the computer memory, etc., which means they have some possibilities that biology doesn't have. We can run them faster in real time. We can accumulate data from lots of different sensors, etc. So they are more powerful than biology in many ways. And about human replacement, well, we have replaced humans for a long time, and I don't think it's going to change much. So certain jobs will be replaced, but it will not be very dramatic. Actually, the jobs that will take are the most boring jobs. So the fun jobs, the more visionary, they will be left to us. They actually require some creative thinking, and I think that's what we all like. And about the tech giants, actually, the main developers of all the algorithms today are guys like this. Here we have Geoffrey Hinton, we have Richard S. Sutton, and John Peters, many others. Maybe not the most representative list, but these are some of the greatest minds. So the development happens entirely in universities so far. And although tech giants are good in finding applications, that is not where we find new technology in terms of new ways to do things. So everything that needs to be known to do applications is already out there in the scientific literature, public information, so they have no advantage if you're a big company or you have a substantial R&D budget, because the amount of money being spent by the giants will not buy you a substantial advantage in terms of technology. It will give you enough money to do the implementations better, but technology will be the same. On the best AI for big data, actually, I mean, about that point is, this is the best AI if you have a huge data set, just a linear classification. It's fast. If the input data is big, it's enough to classify your data, and it's actually quite popular. So if you have big data, you don't really need AI. You can do a lot with a very simple algorithm like this. AI and the more sophisticated algorithms, they come into their own when you have limited data sets. You need to generalize. While you don't have full awareness, you don't have unlimited data. With unlimited data, the problem is trivial. It's when you have a limited data, you need to generalize from that you need the best algorithms out there in order to draw the best conclusions. And about a big R&D budget, this is a typical example of how to create a modern AI with the best implementation. So it's about, 20 lines of code. It doesn't take a lot. Anybody can do it. You can have your 16-year-old son who's just started programming. He can write this code, and you have state-of-the-art AI in any product you want. So it is not necessarily very complicated to implement it. So this is where I think the AI revolution really happens. If you have in your work, your industry or your company does some boring work, you have some data, not a lot. you're not a tech giant, because then you would use other algorithms, and you're willing to do some small R&D, then you're part of the AI revolution, actually. So this is where the real value addition happens with the latest technology. So this is just a brief overview of my views of today. So I want to continue with looking into the future. That's the interesting part. So we know more or less, I guess people have read in popular science at least, what AI science is today. The big question is what's going to happen in the next 10, 20 years, how it's going to change the industry, how will it be able to transform the way we work. And of course, I mean, this is where it heads to. In the end, we're going to have AI that works at humans, but that's not very interesting. Of course, we can imitate biology in silicon eventually, but I mean, is this 100 years ahead or 200 years? We don't know. That is not the part of the discussion. The interesting part is how is the way they're going to look like in the short term. And this is what I think is the big next step in AI, that we move from the classic show a cat, show a dog, and tell it what it is, to reinforcement learning. It's an old problem formulation, but it's become practical. And what we have then, basically, you have an agent, which is the robot there, a mouse. You have an environment, a maze or something, which moves around in, and you have a reward, which can be the cheese. The mouse always can look around it and gets observation. So this is a very general way to solve problems. It can be applied to almost anything. The reward function is more or less identical to a fitness function in genetic algorithms. So if you can do genetic optimization, you can also do this. This is good for learning movements, patterns in robots, etc., control systems in the industry. All you need to do is have a reward function. It can be the profitability of your company, it can be anything. And it doesn't need to be delivered immediately. It can be delivered in the future. So if you want to test the effect and optimize for your profitability for the next 3 years, you can do that using these algorithms. So what has happened now is that we're starting to make this practical in small, simple robots. And if you look at the evolution of the nervous system, we're now at the level of nerve nets. So like simple animals on the left, and also like worms in this level of animals. But artificial evolution is happening, so soon we will reach to more complex animal and movement types, such as running, walking, grasping, etc. And from there on, we will reach also more abstract thinking as natural evolution. So this is what I see as a new way to do programming, actually. Instead of providing the solution to your program, or if you just write a simulation of the problem. So you present the problem. Here, for example, you want to develop a software able to pilot a plane. You create a flight simulator. So it's like the robot school. You can run this in faster than, say, 1,000 times real time, train it very fast, and you let the AI itself develop a behavior and figure out how to do things in order to optimize whatever you want it to do. So I see much more development in creating environments, creating simulators, etc. And then the actual behavior will be emergent from the problem. So if you can formulate the problem, you have solved the problem, basically. And this is just the first step. The next step is coming from dreams. So this is the famous development by Google, actually, in creating dream images, which is somehow lifelike, but a bit more chaotic, more abstract. You can have a lot of interesting art projects this way, but art is not the end goal. The key to dreams is that they are a very simplified but more chaotic simulation of reality. I mean, if you dream, you experience something that is somewhat like the world. I mean, you're a person in your dreams usually. You move, you walk, you talk, you do things like that. But it's random. It changes constantly what you're experiencing. And there are two advantages to this. The first advantage is that you don't need to develop a simulator even. You just have an input flow. You can have a camera, sound recording while you're out flying a real plane. And then automatically your AI will develop a world model. What is it to fly a plane? And it will start flying in its dream and do more random things, try new movement types, etc., new maneuvers. In this way, you don't have to develop a simulator. The AI develops a simulator of its own. It generates new experiences that it has not experienced, and can then, in turn, learn from these simulated experiences. The other advantage is that in your dreams, since they're random, you get a much better mix of experiences. So it's not like you spend one day doing one boring type of job. In its dreams, it transitions between all its previous experiences in a chaotic way. When you learn, it's actually important to have a constant mix. Old experiences, new experiences, do this, do that. And this is what limits your learning speed. So this is a very dynamic environment for it to learn in, and it can learn up to 100 times faster with these kinds of experiences. And this is probably also why almost all animals learn through dreams. So even if you look at small worms, they have sleep cycles and they dream. It's essential to learn at a reasonable speed to sleep and to dream. Now to the part where the AI can supersede the biological intelligence. For example, we can have 1,000 robots. We can then connect them all together into a single AI. So it collects the accumulated experience of all the robots and all the sensors into one mind, able to control each of these single robots. So here, for example, if you run them for, say, 10 days, you can accumulate experience equivalent to a lifetime if you have 1,000 robots. So 20 years of experience in 10 days. So you can get, in this way, maybe a human level of intelligence through 10 days of training, which is entirely new way to learn. Then you can copy-paste intelligences between agents and so on to make them immortal, to take the best student and copy it 100 times and so on. So there are new possibilities of how to do learning. And this is not science fiction. This is being done today in the lab, actually. This is the state of the art, how to train things. If you want to parallelize your training, for example, it's standard you create 10 different agents and then you merge the experiences into a single intelligence. And the final step is we need to have an embodiment for intelligence. And this is going to be a huge development. The big trend today is basically transfer learning. So in order to reach a deeper understanding of the world, you need to first learn one thing and then keep the experiences when you learn another thing. So you need a wide variety of experiences. And this is not being done today. A typical AI is you solve one problem, then you're going to solve another problem, you destroy the AI, you create a new one, and it learns from scratch using just these new experiences. And this works, but it doesn't solve it doesn't create an agent with a deeper understanding of the world. To do that, we need some consistency, a longer lifetime, a wide variety of different experiences of the world that it can draw deeper conclusions from. And to do that, it needs to have some consistency in its form. So, for example, we need to have, if we had one robot able to go, and it can solve a problem on a computer screen, and then it goes and solves some problems using pen and paper, it has something consistent in the way it views the world. So it has the same eyes, same visual inputs. It can separate sound from sound, etc. The sound from visual input. And if you don't have a fixed body, then it becomes too difficult to absorb all these different informations of different formats, different sizes of inputs, etc. So you can't meaningfully transition from one task to another. So once we start having a finalized hardware problem, give an embodiment to the AI, then it can transition more naturally between different tasks. And this will enable us to do transition learning. And then I think from there on, there is nothing known, no known computational limitations that hinder us from just scale things up, add more neurons, more years of experience, and we can reach something similar to humans. Nothing known, we don't know yet. So, well, this was all from me. A bit quick overview of some principles, and I'm hoping for some questions, actually.
Thank you so much. Any questions from the audience? Yes.
First of all, thank you for a very pedagogical talk for a Latin student. And I also feel proud of my parents to see that I'm still ahead of AI. No, yesterday we heard a talk transferred from London from Leonard Johard, and he talked about a whole system approach, and it's no longer cause and effect. That's kind of a mechanic way of thinking. And I think you reached it in your last minutes, but we talk about so complex situations, so there 50, 100, thousands different agents are interfering with each other or interact with each other, I think that's something that the human brain still try to handle. But how possible is it that this can be part of a solution for a new whole system approach that is wiser than our way? Or are AI guys still stuck in the cause and effects way of thinking?
Yes, I think this will be part of the solution indeed. Well, in terms of emergent behavior, we're looking for like some emergent solutions where we don't try to make things smaller and smaller and solve the problem on a very small scale with just cause and effect. But looking at the bigger picture, this is exactly how we try to develop AI. So instead of trying to divide a problem into subtasks and specifying exactly what they are, we create very simple neurons that all are the same, and just when they connect together, they're able to solve problems together. A single neuron is really stupid. It's just a neural classification, linear classification, and that's it. But if you have 100,000 of them, they can simulate basically any problem that we need to solve today. And then you add 100 billion, and we get a human being. So. When we link them, they're still the same, and it's through this collaboration that they create some greater intelligence than each of them possess individually. And I think this is the big problem we face as a society, that if you have 10,000 people in a committee, they don't get 10 times more intelligent, rather like a tenth at best. So if we have the same principles when we organize how people collaborate, then of course this can be very promising. And if we have the same emergent intelligence perspective on society, then we can create something that behaves more intelligent than a single person, which I think is not the case today. And this is essential for democracy to continue, that we need to organize together and take better conclusions using our collective intelligence.
Okay, any other questions from the audience? Yes?
So based on, one of the things is that there's a fear that AI will replace our jobs. And I think what you spoke to is something more along the lines of what are the jobs that humans should be doing versus, so we have a framework of jobs that is more about trying to fit humans into a robotic model because that is what was needed for the industrial economy. However, we're in a different paradigm. So can you speak to that and to maybe perhaps alleviate some fears that AI is not necessarily the threat that we think it is, but maybe it's something that kind of frees us up to be more of who we are?
But I think there's two problems. The main problem there is, of course, we'll be able to be more productive per person with robotics and with AI, but we need to distribute the wealth, of course, in some way. So it's always the same problem. But each person possesses this capability to do some more creative and intelligent work, and the value for repetitive work will diminish. But unless the problem of distribution becomes worse, then the value of more intelligent work will increase. So our overall productivity should increase, and there should be more interesting jobs for us to do. And these things will be handled by AI. I mean, that is the natural solution. But then, of course, it requires a political transition that can happen in any way. It's also doing industrialization. It's the same concept, that it can be worse for some people, for sure, and it needs to be taken seriously. So people who relied on just repetitive work will have a harder time to compete. So it's more important for everyone to get education and so on and be able to grow intellectually.
Well, I've heard that AI, when it becomes aware of itself, that's the end of mankind. How do you respond to that?
Depends on how we program it, but of course AI might request rights and so on if we make it similar to ourselves. So if we just create an artificial human, then we're thinking, why should we do that? I mean, I think we write AI to replace boring jobs. Do we actually need an artificial human? And in that case, it's only because the artificial human is better than a real human. And then we might as well, for example, place our own minds in artificial bodies, etc. And yes, that's to our advantage then. I don't see any like industrial need for artificial robots, artificial humans, but if we create them, it could be a threat, but it won't happen for financial reasons, I think.
Okay, I have a couple of questions. Is it possible to create more people like you? or put it this way, could we do something in our educational system or in society that people will actually have the same passion as you have for artificial intelligence?
Yes, I can say it was not thanks to school, actually.
That's what I thought.
Yes. But of course, I mean, what is passion? I think everybody has a lot of passion. You just need to feel it's possible and then not get their enthusiasm killed by school too much. I mean, I was the worst student all through my years. During school, people used to give me an applause when I entered the classroom because I was never there. And during university, I attended seminars for 6 months. In the last 4.5 years of my master's studies, I didn't attend a single seminar because I didn't find it very interesting. I mean, personally, I'm not a big fan to going to listen to guys talking. I prefer books and so on, but it's not my choice of format. It's interesting once in a while, actually. I do appreciate some good talkers this time. But during university studies, I didn't get the best speakers all the time, especially during school. So I think school could be a threat, and the real passion comes from within, and you find your own information. And I hope that schools gives more freedom to students to study in their own way. I think that is the best way, because that was always needed, and I got this freedom, and I'm very thankful for that. Otherwise, I'll be doing something completely different by now.
Yeah, I think this sums up quite well what we were talking about yesterday. Like each person, each quality, all the different drives that we have, what motivates us, are different sort of talents. That is that society will allow us to sort of flourish within that. And I mean, you're a great role model. Not how perhaps school has been successful, but how a person could actually, by motivation and by finding information, could end up with all this information. Because I know that you have said that you're going to create something that's even smarter than IBM's Watson. Is this true?
Yes. I mean, IBM's Watson is just today's technology still. I mean, well marketed, but it's nothing fundamentally new in terms of how we do calculations. So I'm trying to make the new iteration of doing calculations better. That's the ambition, and I think I'm doing quite well so far. But regarding the inborn talents and so on, I don't really believe in that. I think AI is all about learning. All skills you have learned sometime in your lifetime, so it's more about finding your passions, finding some crazy dreams to follow, and then you will learn through this passion. So humans can learn essentially anything. It's all about passion and giving possibilities to have the right learning environment. So even if you're completely useless at something, if you are motivated, you give it time, you will excel in that.
What?
Why in Russia? Yes. So I didn't cover that a lot, but
the question was, tell us about Russia.
Yes, of course. I studied Russian university. It was interesting, like a cultural experience. I studied also previously in Italy, and I love traveling the world and see new cultures, which gives you new mindsets and new ways to solve things, basically. So Russia has started the first English language university. It's called Innopolis. It's quite interesting. So they are trying to homogenize their university system with the rest of the world. Through this. And they have decent funding. They're looking for new ideas. And a tricky thing today as a researcher is to be able to follow your own ideas, not to get stuck in some pre-formatted project, better designed usually for political reasons and so on, and you do something you don't really like. People in research say the best time is during your PhD because you can actually do real research and you have control over what you do. I think so, yes. Overall, if you know what you want, not everybody does that, but if you have a project you want to do, a new university usually give you the possibility to do that.
Thank you so much. This has been so interesting. A big applause.